Good morning, welcome to Lionheart Academy. This is Richard Tai. We are continuing our trigonometry lessons. Today, this is lesson number 43. We're talking about sum and difference formulas from our last lessons. Now, yesterday I derived the sum and difference formulas, and today let's go ahead and look at some examples more extensively. Okay. Alright, so we did two examples, quick examples yesterday, so let's go ahead and look at some more examples today so you can understand how we can work it out. So for example, let's say we want to find the sine of 15 degrees. Alright, so how should we go ahead and get sine of 15 degrees? Now 15 degrees, to find the exact sine of 15 degrees using sum of difference formula, we can go ahead and use the difference of 40 and 35. Now why do I want to use 40 and 35? Because they are part of our unit circle. So we know the exact answer for 40 and 35 degrees. So and this way we will be easier for us to work it out, the exact answer of sine 15 degrees using an expression. So sine 45 minus 30 will, okay, so let's go ahead and use our sine of difference formula. So it's going to be sine 45 times cosine of 30 minus cosine of 45 degrees times sine of 30 degrees. Alright, so let's go ahead and use our knowledge of the unit circle to evaluate this. So sine 45 is square root 2 over 2. Cosine 30 is square root 3 over 2. And cosine 45 is square root 2 over 2, and sine 30 is 1/2. So this expression came out to be square root 6 minus square root 2 divided by 4. So this expression is the exact, is one of the exact expressions for sine of 15 degrees. Okay, sine of 15 degrees, and we can do that for cosine, for tangent. Let's do one for tangent of 15 degrees. Okay, we did one for cosine yesterday. I think let's go ahead and try tangent. Alright, so this is tangent of 45 degrees minus 30 degrees, and let's use the difference formula for tangent. So that would be tangent of the first angle minus tangent of the second angle divided by 1 plus tangent of the first angle 45 degrees times tangent of the second angle 30 degrees. Okay, so for tangent there will be a little bit different operations because it involves fractions. Okay, so let's work it out. Tangent 45 is 1. Tangent of 30 degrees, okay, at 30 degrees sine is 1/2, and cosine is square root 3 over 2. So tangent 30 will be 1 over square root 3. Alright, now tangent is 1, tangent of 30 is 1 over square root 3. So as you can see, we come up with a complex fraction here. It's 1 divided by 1 minus 1 over square root 3 divided by 1 plus 1 over square root 3. Now, to simplify this fraction, we have to multiply by the denominator. Okay, so the denominator is square root 3, so multiply both sides by the numerator and denominator by square root 3. Okay, so this becomes square root 3 minus 1 divided by square root 3 plus 1. Okay, now this still can be further simplified and rationalized by multiplying by the conjugate of the denominator, which is square root 3 minus 1. Alright, so this will become, the numerator will become 3 minus 2 square root 3 plus 1. The denominator will become 3 minus 1. So this whole thing will be 4 minus 2 square root 3 over 2. And this can be simplified to 2 minus square root 3. Okay, so that is tangent of 15 degrees. It does take a little bit of work, but we're just simplifying the expression, complex fractions, and using conjugates of involving radical terms. Okay, and then we should have no problem. Alright, now let's go ahead and move on to another examples. Okay, now another question that people might come up with is, what about secant, cosecant, and cotangent? Okay, what would the sum and difference formulas of secant, cosecant, and cotangent be? Okay, for example, what would secant of theta plus phi be? Well, secant of theta plus phi, so to simplify secant of theta plus phi is very simple, because we simply use this. It's 1 over cosine plus phi. Okay, and cosecant of theta plus phi is simply 1 over sine of theta plus phi. Now, of course, we can go ahead and expand this and then work it out a little bit, but sometimes it's not necessary, okay? But let's go ahead and try cotangent of theta plus phi, okay, and see what happens. Now, cotangent of theta plus phi is 1 over tangent of theta plus phi. Now, because tangent of theta plus phi is in rational expression, so let's go ahead and work it out and see if we can simplify this. So this is tangent theta plus tangent phi divided by 1 minus tangent theta times tangent phi, okay? Alright, now let's see if we can go and convert this to everything in terms of cotangent, right? Because we have a cotangent theta plus phi, so we want our formula to be in cotangent as well, right? Okay, so how do we do that? Well, first of all, let's recognize that this is 1 minus tangent theta tangent phi, right? Divided by tangent theta plus tangent phi, okay? So this is just the reciprocal of that expression. Alright, then let's go ahead and convert everything to 1 over. So this is 1 over cotangent theta, because that's tangent theta, and 1 over cotangent phi, because that is what tangent phi is. The denominator is the same. It's 1 over cotangent theta plus 1 over cotangent phi, okay? So now I recognize that our denominators has cotangent theta and cotangent phi, so we need to multiply the numerator by those common denominator, cotangent theta, cotangent phi, cotangent theta, cotangent phi, and let's see what happens, okay? Scroll down here a little bit. So cotangent theta times cotangent phi times 1 is cotangent theta times cotangent phi. But cotangent theta, cotangent phi times this expression will cancel it out, so just be minus 1. The denominator, you have cotangent theta times cotangent phi times 1 divided by cotangent theta, so it's cotangent phi plus cotangent theta times cotangent phi times 1 divided by cotangent phi, so it becomes cotangent theta. So this is the sum and difference formula for cotangent. So we don't really have to memorize this formula, but this is very it's just a very nice formula that we can use, but we derived it from 1 over tangent theta. That's why usually we just need to know the sine, secant, and cosine. Sine, cosine, and tangent. Then we can figure out the secant, the cosecant, and the cotangent. But I do want to show you how this came about. Okay. All right. Let's look at some other examples. Okay. So for example, what about sine of 30 plus a? Okay, when you have expressions rather than just all angles together, well, you still go ahead and do the same thing. So sine of 30 times cosine a, right? Plus cosine 30 degrees times sine a. Alright, but we can simplify this because we know what sine 30 is 1/2 cosine a. And we know what cosine 30 is, square root 3 over 2 sine a. Okay, so if you encounter problems like this, you can just simply use the formulas to help you expand it. Now let's take a look at something similar. What about tangent of pi plus a? Okay, plus tangent let's do pi minus a. How do we simplify this expression? Okay, right, tangent of pi plus a. So let's go ahead and use our expressions here. Our formula here is going to do tangent pi times tangent a divided by 1 minus tangent of pi times tangent of a plus tangent of pi minus a. So it's tangent pi minus tangent of a, but in the bottom the sign was switched, so it's 1 plus tangent pi times tangent of a. Okay. Now, okay, let's go ahead and bring it up. Now, what is tangent pi? Tangent pi is 0. So 0 plus tangent a divided by 1 minus 0. Okay, plus 0 minus tangent of a divided by 1 plus 0. So it's tangent a plus negative tangent a divided by 1. So this is actually equal to 0. So those two expressions are exactly the same expressions. Alright. Now, let's look at something a little bit different now. Okay. Now given, okay, sine theta equal to negative 5/13 in quadrant 3, in the third quadrant, and tangent phi is equal to negative A15 in quadrant 2. Okay, so now let's go ahead and see what can we do to find the sine of theta plus. We want to find the theta plus phi. Okay, right, so first of all, we're given several information. Sine theta is in quadrant 3, so let's go ahead and draw a little diagram. Okay, I'm not able to draw it very well today, so let me go ahead and use the tools to help me. Let me draw two diagrams and let's label them. One for theta, one for phi. Okay, so this is quadrant 3. Now in quadrant 3, this is negative 5/13. So the opposite is negative 5, hypotenuse 13. This is angle theta. And by Pythagorean theorem, I know this is going to be, the adjacent side is going to be negative 12. It's a Pythagorean triple. Now what about tangent phi? Tangent phi is in quadrant 2. Now in quadrant 2 is the opposite, so it's negative 8. No, well, the opposite is 8. The adjacent is negative 15 because the opposite is still positive. Adjacent here is negative 15. It has to be negative because it's in the negative x direction. So the hypotenuse, well, should be 17 by Pythagorean theorem. Okay, it's a Pythagorean triple as well. So apparently they give us a very good number here. So this is the angle phi. This is angle phi here. And draw in, okay, this is angle phi. Alright, so now we know everything about those two angles. We can go ahead and answer the question, what is the sine of theta plus phi? Because sine of theta plus phi is going to be sine of theta times cosine phi plus cosine of theta times sine of phi. So we need both information from both angles. So sine theta we already know is negative 5/13, but cosine phi is negative 15/17. Okay, and cosine of theta is negative 12/13 times sine phi. Sine phi is going to be go to A over 17, but it's positive, it's not negative because it's in second quadrant. Alright, so let's go ahead and multiply them together. So negative 5 times 15, that's going to be 65. Now we're going to have 13 times 17, so that's going to be 221. Minus 12 times 8 is 96. Okay, and divide by 221. So we have to subtract the fraction 65 minus 96. That gives us negative 31 divided by 221. Okay, so it's negative 31 divided by 221, and then I don't think we can reduce it anymore, so we'll leave the answer like that. So this is what we can do, and we can go on and find cosine of theta plus phi, or cosine of theta minus phi, or tangent, anything. Once we have both angles, or we're able to find anything else about the two angles, we can find their subtract difference and find the function of their sum. So this is the key of using the function and sum difference formulas. Okay, but the key is you got to figure out which quadrant it is. You got to figure out all three sides, the opposite, the adjacent, the hypotenuse, the x and y, and the r, okay, of that angle. Then we can go on to do this. Now let's go ahead and do one more thing I would like to demonstrate to you. What if we have three angles? Okay, let's take a look at that. What if we have three angles? How do we do, let's go ahead and do this. How do we do cosine of A plus B plus C? How do we convert this to, this is expression, right? A plus B plus C. So how do we expand this? Well, first you can go ahead and view this as A plus B plus C. Okay, so it will be cosine of A plus B. You view A plus B as one angle, right? And then you view, then you can go ahead and expand this out. So this is what's going to happen here. So it's we view A plus B as one angle first. So it's the sum of A plus B and C. So it's cosine A plus B, cosine C, minus sine of A plus B, sine C. Then we can go ahead and expand out cosine A plus B. Cosine A plus B is cosine A, cosine B, minus sine A, sine B. Okay, but this whole thing is multiplied by cosine C, so don't forget that. Now let's go ahead and expand out sine A sine B. So sine A plus cosine B plus cosine A sine B. Now this expression is also multiplied by, in the end, sine C. So actually I should write it like this. Yep. Okay, so let's go ahead and multiply everything out together. So it's cosine A, cosine B, cosine C, minus sine A, sine B, cosine C, minus, okay, so this is going to be sine A, cosine B, sine C, and then minus again, cosine A, sine B, sine C. So let's see, can we combine, are there any like terms? Okay, no, there are no like terms. So that's it. This is the expansion of cosine A plus B plus C. Okay, and we can do the same thing for tangent and sine, and just like that. Okay. Alright, one last thing we like to do is sometimes, okay, they give you expression like this. For example, okay, if they show you sine of 40 degrees, cosine of 15 degrees, plus cosine of 40 degrees times sine of 15 degrees. Can we simplify this expression? Well, we recognize this is actually the opposite of the sine cosine sum and difference formula. This is the result of sum and difference formula. So sine A cosine B plus cosine A sine B. So this is equal to sine of the sum of 40 plus 15. So this actually is reduced to sine of 55 degrees. Okay, 55 degrees. So using this example, we can go ahead and do, let me go ahead and write it correctly. 55 degrees. So using this example, we can combine different expressions. We can actually combine different expressions to write out. For example, let me go ahead and show you a little more complicated expression example here. So let's say we have sine 2 theta plus 3 beta times cosine of 3 theta plus phi, 3 phi plus theta, minus cosine of 2 theta plus 3 phi times sine of 3 theta plus 3 phi plus theta. Now, on the first look, you probably want to expand this. You want to expand this, the sine, cosine, and cosine and sine. But actually, we don't want to do that because you recognize that this is actually an elaborate result of a sum and difference formula. The first angle is 2 theta plus 3 beta. The second angle is 3 phi plus theta. 3p plus theta. Okay. Oh no, it's not beta. I'm sorry. It's theta. Okay. 3 phi. Okay. I'm getting my Greek letter confused. I'm sorry. 2 theta plus 3 phi. Okay, 3 phi. There we go. All right. So as you can see, this is actually our first angle. This is our first angle, right? And this is our second angle, and this is our second angle. So what I can do is I can actually combine this into one term. I can say this is sine of A minus B. So A is 2 theta plus 3 phi. Okay. Minus B. B is 3 phi plus theta, right? So let's go ahead and write this out. So that means I can combine the interior of the sine expression first. So it's 2 theta plus 3 phi minus 3 phi minus theta. Okay. Minus 3 phi minus theta. So actually this is the same as sine theta. 3 phi and 3 phi cancels out, and 2 theta minus theta is theta. So this whole complicated expression, you don't want to go ahead and use the sum difference formula on each one. You will get more too complicated. But if you recognize the pattern, you can go ahead and combine them into one expression. Alright, so today we've done several examples and see how we can use this. So it's very, very useful, sum difference formula. We're going to use sum difference formula to derive the next set of formulas that we need to know for trigonometry. So if you have any questions and comments, please leave them on the question and comment section. And please continue to join us for our next lessons. Thank you.